Okay, so our today's daily lead code problem is minimum jumps to reach end via prime teleportation. Okay, so this question states that we have given an array of integers and we have to find the smallest path possible to reaching n minus 1 from starting from 0. Okay, the simple statement that we have given an array of integers and we have to reach n minus 1 starting from 0 index in the smallest path possible or the smallest steps possible. What do I mean by that? Suppose we are at element 0. Now we have to reach to n minus 1. So we have to find a way to reach to n minus 1, and that way should be the smallest way and the smallest path. So how we will be generating this path, how we are going to generate or how we are going to find this path. So to finding the path, we have basically three rules. The rule says we can move I plus plus one cell only. We can move I minus minus one cell only. And then there is the third rule. This third rule states that our element if our element is a prime number, right? So if our element is a prime number, then whatever element that exist in our array which are completely divisible by our prime number can be reached directly. Okay, so the first rule was each index can move right, each index can move left, and also if that particular element on that index is a prime number, then that index can jump directly to those numbers which are directly divisible by this prime number. For example, suppose we are on index 1 where the value is 2, and now 2 is a prime number very firstly, right? 2 is a prime number. So in the array, we can see that 4 is left, 6 is left, right? So we'll check whether our 4 is completely divisible by our prime number, basically 2, or not. If it is, we can directly jump to this element rather than moving adjacent sides or moving one cell at a time. Similarly, if we choose 6, 6 is also divisible by 2. So we can directly move to 6, right? So using these rules, what we see that when we were on 1, 1 is not a prime number. So we moved right since left was out of bound, right? So we moved right. When we moved right, we reached 2. Now 2 is a prime number. 2 can directly jump to 4 or to 6. Our target is to reach 6. And now 2 can directly jump to 6. So how many steps does this one takes to reach our n minus 1 element? One step here, one step here. Overall, two steps. In these two steps, our index starting from 0 reach our n minus 1 index, right? But what we have to do, we have to find for all the elements, we have to find the smallest path to reach our n minus 1. If there any smallest path to reach 6 from 0, we will be returning that, right? Alright, so this particular question is basically a question where we have to find the shortest path or the smallest steps, right? So in such questions, the basic approach or basic intuition that comes to the mind is using BFS or DFS for now. Okay, so here I am going to use our BFS approach, the breadth first search traversal. If you don't know about this topic, I would suggest go and just watch a 20-minute video. You'll understand how BFS traversal works. Okay, so basically BFS traversal works on a graph kind of data structure, right? So I have already shown you that when we are creating the path, it creates a graph like structure. Correct. So this is not a question of array. This is a question of graph technically. So to resolve this or to find the solution for this problem, we have to go to the BFS approach very firstly. Now how this BFS approach will work. So for now, skip this part. If you know BFS, well and good. If you don't know the BFS, just skip this part. And once you move forward, I would suggest go and watch the BFS traversal video first. Then this problem or this explanation will get into your mind clearly. Search what we generally have. So we generally have a queue that this algorithm always have. Then we have a solve this question. What we generally use, yeah, to solve such problems, what we generally use, we basically take a queue. Then we have a visited array. Okay, the visited array. This is nothing but queue, and this is our integer array. And to set up the BFS traversal, our job is to put the zero index in the queue, 0, 1, 2, 3, and make it true that it is visited. Okay, now the iteration will start. So we will be iterating while our queue dot not is empty. So until our queue have something in it, we will be keep on looking for the steps. Okay, so very firstly we started from 0. It is already visited. Now we come into the loop, and our task is basically to find the shortest path for each level. So suppose we are on 0th level, then this is 1 level, then this is 2 level, and this is 2 level. It is 1, it is 2, it is 4, and it is 6. Level 0, level 1, level 2. Okay, now our BFS traversal goes for each level and find all the edges. Find all the edges that is adjacent to our current level. Okay, how it does that? Let's see. So very firstly we put 0, our first index in the queue, and that is visited as well. We have marked it at marked it as visited. Okay. Now we'll loop for I is equals to 0. I should be smaller than q dot size I plus plus. This q dot size denotes how many elements are on the same level for this current index. Okay. So once we reach q dot size, so basically here q dot size is nothing but 1 only. Now we started from index 0. So when we started from index 0, we check move right, move left, and what was that term? Okay, prime teleportation way, right? Basically, prime teleportation way. So there are three manners, three options. Okay, so now what we'll do? We'll come here. We check on the we are on the index 0. We check move right. Can we move right? Can we move right? Yes, we can move right. Okay, we can move right because I is not a prime number. We can move right in uh, one step at a time, correct? So we can move right. So once we move right, the next index that comes up is 1. So what we did, we added 1 in the queue. Okay, now can we move left? No, we cannot move left because left is out of bound. Can we check from prime teleportation? No, prime teleportation cannot be happening with 1 because 1 is not a prime number, right? So once this 0 is done, we check our index is 0. I should be smaller than q dot size. Q dot size is nothing but 1 and our 0 is smaller. So once we I plus plus, it will become 1. So we'll go out of the loop. So our first level is completed. By completing our first level, what we observe that put we have taken one step towards right? So we will update our step plus plus. Initially we'll keep our step equals to 0. Okay, clear here, clear till here. So now 0 is completed, so we will remove 0. Now we have 1 in our queue for now. All right. Okay, so now we moved out of the loop, we implemented the plus plus. Now we check either queue is empty. No, queue is not empty. Queue has one element, right? So again we come here, we check index is 0, queue size is basically 1, I plus plus. Okay, so we check move right. Can index 1 move right? Can index 1, can our index 1 move right? Yes, it can move right. Also, I missed one thing. When we added 1 in the queue, we also have to mark it as true, that it is visited. Now, back here. We are at 1 and we wants to move to right. Can we move to right? Yes, we can move to right. We are at index 1. Can we move to right? Yes, we can move to right. So what we did, we added 2 and marked it as true in the queue. Now next we check, can we move left? Can we move left? Yes, there is an option for moving left, but we will check, is it visited already? So index 0 is already visited, so we will skip it. We won't move left. Now we'll check prime teleportation. 2 is a prime number. Yes, 2 is a prime number. So 2 can move to 4 and 2 can move to 6. Means 1 can move to 2 and 1 can move to 3. So 1 can move to 2. 2 is already marked visited. So we will skip 2. Now 1 can move to 3. 3 is not marked as visited. So we'll mark 3 as visited and we will add 3 here. Okay. Now we come here, we check whether our queue size is smaller. So now I is equals to 1 and queue size is also 1. So we'll go out of the loop. We'll go out of the loop. So once we go out of the loop, we will update our step. Now step become 2. Once 1 was added previously, then it got added now. So it become 2. Now in our queue we have 2 and 3. Remove 1. Okay. So now we are out of the loop. Once we are out of the loop, we check queue is empty. No, queue is not empty. This time queue has size 2 and we are at 0. So we are starting from 0, which is nothing but the 2. Check, can we move right? Can we move right? Yes, we can move right, but that is also visited. So we will ignore that. Can we move left? Yes, we can move left, but that is also visited. So we'll skip that. Prime teleportation, is 4 is a prime teleportation? No, 4 is I mean 4 is not a prime number. So we'll just move forward. So we'll go out of the loop and this time I is equals to 3. Now we'll check for 3. Can 3 move to left? No, 3 cannot be moving to left because in this case it will be out of bound, right? So uh, can 3 move left on the 2? 2 is already visited, so we are not going to move to 2. Now we'll check prime teleportation. Is 6 a prime number? No, it is not a prime number. So we'll move out of the box. Our all the elements have been iterated and our queue become empty because once 2 was done, 2 moved, we left with 3. Now 3 is already done. So queue become empty and the steps that we got to reach our n minus 3 is basically 2. All right. So we discussed about the dry run. Let's move to the code. I'll try to explain. I'll try to make you understand about the code, how code is working. So let's move to basically this part. Okay. So here we have a main function, which is nothing but calling our min jumps function. Okay. Now this is the min jump function. Here what we are doing, very firstly, we took out the length of our nums. Then we created a queue, basically a linked list. In our BFS, as I said, in our BFS, we need a queue and we need a visited array, right? So we created a queue and we created a visited array, which is nothing but a boolean. All right. And to set up our BFS traversal, very firstly, we have to put our 0 element basically in our queue. Okay. Not the element, basically the 0th index in our queue, and we have to make true our 0th index in the visited array. This is the prerequisite for setting up the BFS traversal. So we created a queue We created a boolean visited array. We added index 0 in the queue. We marked true in the visited, we marked index 0 as true in the visited array, and then we have a steps that is taking the counter for our steps to reach the n minus 1 values or n minus 1 index. Okay, now we started while q dot is empty. We started that if q is empty, we take out the size of the q. Basically, what this does, this makes sure that we do not merge levels, because BFS always works on level wise, level 0, level 1, level 2, and all the possible scenarios on such levels. Okay, so this is that. So for currently in our queue we have 0 element, which is nothing but with the size of 1. So in current size there is 1. Then what we did, we started a loop. We started a loop on the level elements. So for now on the 0th level we have only one index which is 0 and one element which is 1. So we are iterating on that, and what we are searching and what we are looking, the steps that we discussed, right? So very firstly, what we did, the we pulled out the index that is currently exist in our queue in current. Now we'll check if current n minus 1, this is the base case. If current is equals to n minus 1, means once the current reached to our n minus 1 index, return steps. Whatever the steps are taken to reach n minus 1, just return the steps. Okay, so this is the first base case. Now the main core logic starts where the checks are there. We can move left, we can move right, and we can move on the uh, indexes, teleported indexes, which is directly the factor of our prime number, right? So let's see what we did. We were on 0. We came here, we checked this part. Now we check, can we move left? No, we cannot move. Can we move right? Yes, we can move right. So once we move right, what we did, we added that index, the right index, basically the current plus 1 index in the queue, and marked that visited. Here, once we take this 0, once we take this 0, we come here, we check, can we move left? No, we cannot move left. Can we move right? Yes, we can move right. 0 can move to 1. So once 0 can move to 1, what we did, we added 1 in the queue, and we added 1 as a visited array. We marked 1 as a visited array so that it won't get counted in the next iteration. So there won't be any duplicates, right? So similarly here we checked left was not there for 0 index. Then we checked right was there for 0 index. 0 can move to 1. So we moved to 1, we added in the queue, and we marked as true. So the first element is marked as, so first index is marked as true. It means we have visited our first index and we added in the queue. Now this part is done. Now the third check. We'll check we are getting the value. Before it was indexes, so we are getting the value. So now what we'll check? We will check whether our current element is prime or not. If it is prime, we will add all the possible uh, factors which exist in the array, right? Because if the number is prime, we can directly jump to that element. So we are finding that whatever elements are there which are directly divisible by our prime number. means our current index. How many elements are there in our current indexes? How many elements are there in our array which is divisible by our current element? If it is directly, if it is divisible and returning 0, it means we can directly jump to that element. So what we did, we added in the queue and we marked as visited. And once the loop is done for first level, or you can say the one level, it was one here. So once the level one is done, we iterate all the possible paths for two. We will add it in the queue, that will be 2 and 3, right? 2 and 3, and we marked as true in the visited array, and we move out of the loop. So once we move out of the loop, once the loop, basically the level loop is completed, then only we add the steps. So basically one level is completed, we can add the steps. So we added steps plus plus and then move forward. We check if queue is empty. Now queue has two elements, 2 and 3. Now we'll try to find the same process for 2 and 3 as well, and we'll look whether how 2 is going to reach to basically n minus 1, and 3 is going to reach n minus 1. So the once the current is n minus 1, basically once we reach n minus 1 is equals to 3, we'll go out of the loop. So iteration is completed, queue is empty, and we have returned the answer with true. Let's run it and see the example. So this is basically 1246, right? The same user, same example. What we did, we tried to run it. We got the right value. Let's see for some different use case. What will the use case? Let's take this. Okay. What is the output here? It is true. See, even we are getting 2. So that is done. But there is some optimizations, I would say. What are the optimizations? I am letting you know. I would say that you better go and ask, find for this optimized approach. So here what we are doing, we basically checking all the factors in particularly the whole array. So suppose if we are on some element, our current element is a prime, so we are checking the whole array for the factors which are directly divisible by our prime number. So every time when we are changing our index, we are iterating the whole array again and again to finding the factors of our prime number. This is itself is taking O n square time complexity. So this is the part where optimization is needed. So I would say better go and research and find the optimal way that we can apply here, right? All right, thank you so much. If is there is any doubt, or if there is any question, please feel free to ask. Put it in the comment box. I'll try to answer it as soon as possible. Thank you so much. Have a great day.